In this video, we'll be looking at cases involving indices as powers, showing the subject formula, cases involving indices or powers. Now, make x the subject of the relation y plus q squared plus x squared over c. So, first of all, let's start by eliminating t from here since we are going to make x the subject formula. So to do that, multiply both sides, multiply both sides by t. So t times y is equals to square root q squared plus x squared over t times t. Cancel. So t y is equals to square root q squared plus x squared. Next is to remove the square root sign. So to do that, we need to square both sides. Square both sides. So ty squared equals to q squared plus x squared all squared. These two will cancel the square root sign. So this will give us t squared y squared equals to q squared plus x squared. So next is we're going to eliminate q squared from here. To do that, we subtract q squared from both sides because this is addition. Subtract q squared from both sides. So c squared, q squared, y squared minus q squared equals to x squared, which can be written as x squared equals to c squared, y squared minus q squared. Next is to take square of both sides because we want x squared to stand on this one. So we want to eliminate its power. To eliminate power, we're going to take square root of both sides. Take square root of both sides. X is equal to c squared, y squared minus q squared. So the power will cancel the square root sign. Therefore, x is equal to square root c squared, y squared minus q squared. Now, x is the subject of the formula or the relation. Number 2, A4A3 is equals to c minus b squared. Find the value of b when a is equal to minus 7, c is equal to 84, correct to dp. So substitute these values into the equation. We must make b the subject formula because the question says we should find the value of b. Meaning that b should be the subject of the relation. So first thing we're going to do is to eliminate c from here. And to do that, we need to add c to both sides because of the side, the relationship between c and b is subtraction. So to be able to eliminate c from here so that b stands alone, we need to add c to both sides. So to add c to both sides, the fourth a is equal to plus c equals to c plus plus c minus b squared. Oh, I'm not going to add c to this. I'm going to subtract c from the side because c on here is positive. This minus is called b squared. So c is positive. So I'm going to do subtraction instead. Subtract c. Subtract c from both sides. C is positive, so I'm going to subtract c from both sides. C minus C minus C. 4A is equal to minus C. A minus C is equals to C plus C minus C is 0, so minus B squared. It will not be nice that the later one to the subject formula is negative, get minus. So what we do is that we're going to make it positive. To do that, we're going to multiply through by minus 1. So multiply through by minus 1. Minus 1 or e raised to power 3 minus c equals to minus 1 and b squared. So this equals 4 e raised to power 3 plus c plus 2 b raised to power 2. So we can write this part as c minus 4a raised to power 3 equals to b2. I say b2 b raised to power 2 is equals to c minus 4 e raised to power 3. So we cannot leave our answer b cannot stand alone as a later raised to a power. So what we do is that we will eliminate the power. So do that is a take square root to both sides. Take square root of both sides. So b squared is equals to c minus 4d raised to power 3. The 2 here cancel this 2. B is equals to c minus 4e raised to power 2. So this one b is the subject formula. Now we're told to find the value of b correct to 2 decimal place. So when e is equal to minus 3, we want to say when e is equal to minus 3 and c is equal to 24. Therefore b is equal to square root 24 minus 4 minus 2 is equal to, so the question is 24 minus 3 raised to power 3. So minus 3 raised to power 3 implies minus 3 should multiply itself 3 times. Minus 3. So minus times minus is plus, plus times minus is minus. 3 times 3 is 9, 9 times 3 is 27. So the answer is 4 times minus 4. So 4 times minus 27. This is equals 4 to 24 minus 4 times minus 27. 108 minus 108 versus 24. Minus times minus is plus 108. So we're going to have 24 plus 108. Square 132 is 11 points 489 1. The question says we should approximate or get it correct to 2 decimal place. So this is the first, this is the second. So the 2 decimal place approximated we use 11.49 to 2 dp. That's the answer. Actually, it makes C the subject of relation P and square root C minus 3, C minus 9. So to make C the subject, the first thing to do is first of all remove n from here. N is related to this part by multiplication, so we're going to divide both sides by n. Here with k over n plus the n square root t minus 3 t minus 9 over n. So n one k over n equals to square root t minus 3 t minus 9. So to continue with making t subject formula, first thing we need to remove the square root sign. So we say square both sides. Square both sides. So k over n squared equals to root t minus 2 t minus 9 all squared. So 2 we cancel the sign. K squared n squared equals to t minus 3 and t minus 9. So now we're going to cross multiply. So t minus 9 k squared t minus 9 n squared t minus 3. So we are going to expand k squared t squared t minus 9k squared plus n squared t minus 3 n squared. So since we are going to make t subject formula, so we'll bring the ones that the letters that have t joined to it. So this one has t and this one has t, so we'll bring them together. So this will come over, so it becomes k squared t minus n squared t. And here will be minus 3n squared minus 3n squared minus 9 plus k plus 9k that's 9k squared. I'm going to write this part as a k squared t minus n squared, because since it's positive, you can write it first now. K squared minus 3 n squared. So factor to add c out. So I'm going to factor out t. So t is k squared minus n squared plus 9k squared minus 3 n squared. So divide both sides by k squared minus n squared. So that we can eliminate all of this from here, and t is stand on its own. So t k squared minus n squared over k squared minus n squared equals to 9k squared 3n squared over k squared minus n squared. Then cancel. So t is equals to 9k squared minus 3n squared over k squared minus n squared. So t is the subject of the relation. This is if okay, so find the value of t if k is 2 and n is equal to 1. So I'm going to write it. T is equal to 9 k squared minus 2 n squared over k squared minus n squared, where k is 2, and n is equals to 1. So t is equals to, in place of the letters, you put the values, respective values. 9k is 2 squared minus 3, 1 k 2 squared minus 1 squared. 2 raised to power 2 is 4. 4 times 9 is 36 minus 3 times 1 is 3. 2 raised to power 2 is 4 minus 1 raised to power 2 is 1. 36 minus 2 is 33. So t is equal to 33. 4 minus 1 is 3. This is divided by 2 is 11. 2 is 1, 2 is 11. So, therefore, C is equals to 11. Number 4. A is equals to 1 over 2. B plus 1 over 8. C squared over B. So we have to make C the subject of the formula. So this part is multiplication, this part is multiplication. So what we have is that we have a fraction. So the first thing is to simplify the fraction. So the answer of 2 and 8 is 8. So A is equals to 8. 8 into 2 is 4. 4 times B is 4B. Plus 8 into 8 is 1. 1 times C squared plus B, that will be C squared over B. So the next thing is to take away 8 from here. You can do that like multiplying both sides. Multiply both sides by 8 because this is division. So to undo division, we have to multiply. So 8 is equals to 4b plus c squared over b over 8 times 8. 8 here 1, 8 here 1. So 8 is equals to 4b plus c squared over b. The next thing is to eliminate this part. And to do that, we have to subtract 4b from both sides. 8a minus 4b is equals to 4b minus 4b plus c squared over b. So here will be 0 plus 4b minus 4b will be 0. So 8a minus 4b is equals to c squared over b. The next thing is, since I'm trying to make c solid formula and b is still here, we need to eliminate b. C squared is connected to b by division, and to undo division, in order to make c the solid formula, we need to multiply both sides by b so that b can be eliminated from here. Let's say multiply both sides by b. So b 8a minus 4b equals to c squared b multiplied by b. So b and 1, b 1. So c squared is equals to b 8a minus 4b. I can expand, so this is equal to 8ab minus 4b squared. Now, our intention is to make c the solid formula, not c squared. So we need to eliminate the power. To eliminate the power, we're going to take square root of both sides. Take square root of both sides. Take square root of both sides. So once we take square root of this other side, then we have plus minus equals 8ab minus 4b squared. I think this because plus minus, because square root sign, once you take square root both sides, our answer is the square root of any number is going to be either positive or negative. But you might wonder, but what about other examples where I took square root of both sides and I didn't put plus or minus? I just sometimes can ignore it because there's no point taking the negative value of the square root. Most times we only take the positive value of the square root, but it's still advisable you put the two signs, except in case where if it's an objective question and you check your options, you see the sign, you just know that in that particular instance you need to include the plus or minus sign. But usually whenever we take square root of a number, it is the square root of a should be plus minus a. So, but we usually ignore this plus minus because we always go with, or we frequently go with the positive value of the square root. or usually supposed to be plus or minus. So c squared plus or minus 8a so minus 4b squared. C is equals to plus minus 4b is common, so factor 4b out. This is 2a minus b. So c, because the square root of 4 is 2 plus or minus 2 square root b 2a minus 3. So c is the subject of the formula. Make R is subject of the formula Q equals to P 1 plus R 100 is equal to we want to make R stand alone. So the first thing we need to do is remove element P from here. So we say divide both sides by P. So Q over P equals to P 1 plus R over 100 plus 2 over P. P1 P1. So Q over P equals to 1 plus R over 100 over 2. So the next one we're going to eliminate is our power. To eliminate the power, we're going to take square root of both sides. Take square root of both sides. So take square root of both sides, that will be Q over P squared plus 1 plus R over the square root of both sides. That's what I said. So that's 1 plus 1 plus R 1 plus R over 100. So 3 over here we cancel. So let me write this here 1 plus R over 100 equals to square root Q over P. The next thing is to eliminate 1 from here. To do that is subtract 1 from both sides. R 1 minus 1 plus R over 100 equals to square root of Q over P minus 1. 1 minus 1 is 0. R over 100 is equals to square root of Q over P minus 1. So we need to eliminate 100 from here. And yes, the relationship between R and 100 is division. So multiply both sides by 100. So eliminate 100 from here. So 100 times R over 100 equals to 100 times square root of Q over P. Okay, so like this. This is going to multiply everything in the bracket. 100 Q over P minus 1. So this 100 is going to multiply everything inside this bracket. So here 100 into 101, 101. So R is equals to 100 square root Q over P minus 1. So R is the subject of the formula. B part says find correct to three significant figures, the value of R when Q. I'm going to write the formula again. R is equals to 100 Q over P minus 1. So where Q is equals to 6 to 5 and P is equals to 2 to 5. 2 to 5. So therefore R will be 100 equals 625 over 225 minus 1, and that's 100. The square root of 625, 625, square root of 625 is 25, square root of 225 is 15 minus 1. So now we have a fraction to deal with. Solve this fraction, 25 over 15 minus 1 over 1. First of all, let's see if we reduce it. 5 here will give us 5, 5 here 2, so that's 5 over 3 minus 1 over 1. We can say 100, 5 over 3 minus 1. So now let's go for the simplified form of this fraction. So LCM is 3, 3 into 2 is 1, so 1 times 5 is 5, 3 into 1 is 3, 3 times 1 is 3. So 5 minus 3 is 2 over 3. That's equals to, so here everything here will be 100 over 2 over 3. So 100 times 2 is 200 over 3. So 200 over 3 is equals to 3 into 20 is 6. 6 times 2 is 18. 10 minus 8 is 2. 3 minus 0. 3 into 20 is 6. 6 times 3 is 18. That's 2.0. 3 into 20 is 6 again. 6 into 3 is 18. That's 206. So it will go on. So answer is 66.66 continuously. So we're told to approximate or give our answer correct to 3 significant figures. So which means 6 is going to be 6666. So let me put up to 4, 6666. So this will continue. So the answer is equal to 66 points. So 3 significant figures. This is the first significant figure, the second and the third. So the fourth is more than 5. Add 1 to the 7, 66.7 approximately. So 3 significant figure, 66.7. So I see. So given the formula 100 over p 1 over n minus 1 equals to r. So it's to make r the subject of the relation. So it's supposed to make e. R is already the subject of the relation. So make e the subject of the relation. So that we're going to make e the subject of the relation. So to do that, we need to eliminate r of 100 from here. So we divide both sides by 100. 100 e over p over p 1 over n minus 1 equals to r over 100 over 100. The 100 here 1 100 e over p 1 over n minus 1 equals to r over 100. Next thing to eliminate, or take out of the way for us to be able to make a the subject of the relation is minus 1. To do that, we will add 1 to both sides. Add 1 to both sides. So a over 2 raised to the power of 1 over n minus 1 plus 1 is equals to r over 100 plus 1. So here will be 0. E over p 1 over n is equals to r over 100 plus 1. Now, this is 1 over n, so we're going to take square. So square, we are going to take the n power of both sides. Take the nth power of both sides. Remember that if this were indices, assuming it was something like a over p equals 1 over 2. You need to eliminate p, or to be able to eliminate this fractional power so that we can make a solid formula on this side. We're going to take the square root of both sides. We're going to square both sides because this is also equals to what we have here is still something like this, a over p. So if you square both sides, then here will be raised power 2. 2 times 1 will give us 2, and then 2 here 1, 2 here 1, so it will be a over p. So same here, because this is n and doesn't have a value, we're going to take square both sides, but to be to the power of n. So take the square of both sides. Take the square of both sides in the power of n. In the power of n. That is take the nth power of both sides. Take the nth power from both sides. So when we do that, this will give us e over p one over n power plus r over 100 plus 1 raised to power n. So n times 1 give us n divided by n will be 1. So it's going to be e. So e over p is equals to r over 100 plus 1 raised to n. Since I'm making a solid formula, we need to eliminate p. To do that, the relationship between a and p's division, they are connected to each other with division. So to undo division, in order for p to be taken away from here, we need to multiply both sides by p. Multiply both sides by p. So p times a over p equals to p bracket r over 100 plus 1 raised to the power of n. So p here 1, p here 1, a is equals to p r over 100 plus 1 raised to the power of n. This is the formula for amount. So this is the area. Sorry, this is the relation when a is the subject of the formula, and this is the formula for amount in compound interest and simple interest. Let's go. So it says number 2 of which is this is my figure 1. So let me start my figure 1. So my figure 2. My figure 2 says find the value of a when p. So I'm going to write the formula again. So amount, so this a is equal to p r over 100 plus 1 raised to the power of n. So where p is principal 7808 n theory, and r, which is the rate, is 25. So e is equals to 7808 over r, which is 25 over 100 plus 1 all raised to the power of 3. So the amount is 25 here. Yeah, we can do it that way, but since the fraction, yeah, we can still reduce it. 25 over 100, 25 here 1, 25 here 4, so that goes to 1 over 4 plus 1. So 7808 1 over 4 plus 1 all raised to the power of 3. So let's simplify this fraction. As we also know the denominator is 4, 4 into 4 is 1. 1 times 1 is 1 plus 4 into 1 is 4. 4 times 1 is 4. So that's 5 over 4. So that's 78085 over 4. All raised to the power of 2. E equals 7808 over 5 divided by 4 is 1.25 raised to the power of 2. That's equals to 7808 times 4. 1.25 raised to the power of 2. That means 1.25 should multiply itself 2 times. 1.9, 1.953, 1.9531, 3125. So multiplied by 78. So 1.953125 multiplied by 7808. 15,250. 15,250. The question. Okay, so you need to tell us to give correct the answer to any significant number of significant figures. So you will leave it like this. Solution number 1. Given the relation C is equals to U 1 over F plus 1 over G. Make G the subject of the relation. So to make G the subject of the relation, we first of all need to simplify this fraction and then clear off. The first thing is to clear off. Let's clear off the square root side. So we say square both sides. Square both sides. And have C raised to the power 2 equals to okay. So U over 1 over F plus 1 over G all squared. So 2 cancel the square, so T squared is equals to U over 1 over F plus 1 over G. The next is to simplify the fraction. Simplify fraction. So 1 over F plus 1 over G. The LCM of the denominator is FG. So FG into F is G plus FG into G is F. So G plus F over FG. C squared is equals to U over C G plus F over FG. Now what we're going to do next is we're going to, since G is our focus, we're going to multiply both sides by okay, so we are not done with this part. So let's go on. C squared is equals to U divided by G plus F over FG. So C squared is equals to U times so since it turns to multiplication, then FG will be here and G plus F will be here. So UFG or FGU. So T squared is equals to UFG over G plus F. Now we're going to cross multiply, make it to 1. So it's a cross multiply. So we cross multiply, this part will multiply here. So T squared G plus F and 1 to multiply UFG. So we open our bracket. T squared G plus C squared F. We're going to collect like terms according to UFG. We want to collect like terms. We mean the terms that have G in common because we want to make G solve the formula, and G is occurring in two sides of the equation. We have G here and we have G here. So we need to move to bring something over here because UFG T squared moving over top minus T squared G. This one is here, so T squared F. Okay. So the next thing is to factor out G. Factor out G. So G is UF minus T squared. So T squared F. So divide both sides. Divide both sides by UF minus T squared. So G UF minus T squared over UF minus T squared. Because T squared F over UF minus T squared. Yeah, so this will cancel. And this will cancel. So G is equals to T squared F over UF minus T squared. That is subject formula. Find G when T is 3, F is 4, and U 5. So I'm going to write okay. So take this part of the board. So let's see my figure 2. So I'm going to write the first part of the equation again. So G is equals to T squared F over UF minus T squared. So I'm saying where T is 3, where T is 3, F is 4, and U is equals to 5. So T, so G is equals to T, which is 3 squared F times F, which is 4, over U, which is 5 times 4 minus 3 squared. So 3 squared, 3 times 3 is 9, times 4 over 5 times 4, 20, 3 times 3 is 9. So that's 36 over 20 minus 9 is 29, 10 minus 1, 1, and then you have 1, that's 11. 36 divided by 11, that will give you 3 whole number, 3 over 11, 3 over 11, that's the final answer. And 2 equals to Q R minus T 15 over 2. So we have to make T the solid formula. So first thing we need to do is eliminate this fractional power over 2. To do that, we're going to raise both sides to power 3. Raise both sides to power 3. Both sides to power 3. So P raised to power 3 is equals to Q R minus T over 15 1 over 3 raised to power 3. So 3 times 1 give you 3. 3 divided by 3 is 1. So that will eliminate the fractional power P raised to power 3 is equals to Q R minus T over 15. Next is to take away 15. So multiply both sides by 15. So 15 times P raised to power 3 Q R minus T over 15 times 15. 15 P raised to Q R minus T. Next, so take away Q. To do that, we divide both sides, by q. 15 is equal to q r minus t over q over q1. So r minus t is 15 p is equal to over q. So yeah, to make t the solid formula, and so which means c will have a standard. So r will move to this side. So this will give us minus t. Okay, so this subtract r from both sides. Subtract r from both sides. So r minus t, that's 15 p raised power 2 over q minus r. So plus r minus r is 0, minus t is equal to 15 p raised power 2 over q minus r. T is standing alone, but it's negative, and we don't want, when the later is made subject of a relation, it doesn't have to be negative, so we're going to multiply through by minus 1 so that t will be positive. Multiply through by minus 1. So minus, and ignore the 1, minus t equals to minus 15 p raised power 2 over q minus r. So minus times minus is plus, minus times plus 15p raised power 2 over q gives us minus 15p raised power 2 over q. And then minus times minus gives us plus r. So it will not be nice when this part is positive and this side is negative, so we're going to rewrite it. So t is equal to bring positive later here, r then minus 15p2 over q. So that's our answer. So this way t has been made the subject of the relation. Solution number 1. Given that h is equals to 2p plus q over p minus 2q, 1 over 2. Express p in terms of q and h. So we want to make p subject formula, but there's an obstacle here. So first thing to clear it off, that's fractional power. To eliminate that, you're going to square both sides. Square both sides, so h squared equals to 2p plus q, p minus 2q. So 2 times 1, 2, 2 divided by 2 is 1. So h squared is equals to 2p plus q over p minus 2q. So the next thing is to cross multiply. Either you cross multiply or you multiply both sides. Okay. If I'm going to cross multiply, I'll make it to be over 1, so that will be a fraction. But if I don't want to go use cross multiplication, I will multiply both sides by the new denominator, because this division, in that case I will not make it to be over 1. So cross multiply both sides by p minus 3q. So p minus 3q here will cancel this part and then we'll multiply through. So cross multiply over 1, so p minus 3q h equals to 2p plus q multiplied by 1 very center. So h p minus 2h q equals to 2p plus q. When you collect terms in p, so collect terms in p. So 2p and h are common, so h p is equal to minus 2p q plus 2h q. So factor out p. factor of p. So have p h minus 2 equals to q plus 3h q. Next is to divide both sides. Divide both sides by h minus 2 p h minus 2 h minus 2 plus q plus 2 hq over h minus 2. So this will cancel. Yes, q is equal to 3 plus 2 hq over h minus 2. That's number one. Then number two, if v squared, so write out formula, v squared is equal to u squared plus 2as. What is or are the values of u when v? So if the question is asking us for the values of u, it means u has to be a subject formula. So let's do that. So to make u the subject formula, let's eliminate this part. Take this addition to subtract 2as from both sides. So v squared minus 2as plus v squared plus 2as minus 2as. So this will give you 0. U squared plus v squared minus 2as. Now since this is raised to power 2, we need to eliminate it. We're going to take square root of both sides. Take square root of both sides. So this u squared equals v squared minus 2as. So u is equal to square root plus or minus. Plus or minus, because question gives us option. What is or are? So it's only when we have positive and negative that we're going to have two values. V squared minus 2as. So this u being the subject of the relation. So we're going to say where u is equals to 7, a is 10, and s is 2. So u is equal to plus minus v is 7 squared minus 2, a is 10 times 2 plus minus 49 minus 10 times 2 20 minus 2 20 times 2 gives us 40. So this equals to plus minus 49 minus 40 is 9. So u is equals to plus minus square root of 9 is 3. Therefore, u is equals to 3 or minus 3. So u is equals to plus 3 or minus 3, which is the meaning of plus minus 3. So if s is equals to a squared plus minus square root b squared minus c over 2a. So we're told that where a is equals to 2, b is minus 2, and c equals to minus 3, to minus 5. Minus 5. Find s. So s is equals to 2 squared plus minus b minus 2 squared minus 5 over 2 times 2. This is 4 plus minus 2 times minus 2 is 4. Minus times minus 1 times minus 5 plus 5 over 2 times 2, 4. So 4 plus minus square root 9 over 4. 4 plus minus 4 of 9 is 3 over 4. So this is equals to 4 plus 3 over 4, or 4 minus 3 over 4, which is 4 plus 3 is 7 over 4, or 4 minus 3 is 1 over 4. Therefore, 7 over 4 is 1 over 3 over 4, or 1 over 4. Therefore, S is equals to 1 over 3 over 4, or 1 over 4 over 4. If Z is equals to square root x over n minus n over y. So make y the subject of the formula. So for us to make y the formula, we're going to eliminate the square root sign. So say square both sides. Square both sides. So z squared is equals to zx over n minus n y. To cancel this. Z squared is equals to x over n minus n over y. The next thing we are going to do is to look for else to simplify this part, since it's a subtraction fraction. So denominator z squared is equals to n y. My divided by n is y. Y times x is xy minus ny divided by y is n times n. So next thing is to I'm going to multiply both sides. I could cross multiply by making a fraction, the cross multiply, but I don't do that. Let me multiply both sides. I'm multiplying because to be able to eliminate ny, since this division, I have to do the opposite of division, which is multiplication. Multiply both sides by ny. So z squared times n y is equal to xy minus n over n y times n y. So here cancel 1. So z n y. So say n y z squared is equals to n y z squared is equals to x y minus n. Okay, so it's called that x y and y n y z squared. This term and this term, they have y in common, so I'm going to collect terms in y. Collect terms in y. So this will move over here, this will move over here. So x, y, when this move over here becomes minus n y z squared. And then this will move over here to become positive n. So I'm going to factor out y. Why are we factoring out y? Is because we intend to make y the subject formula. That's the question tells us to do. So y x minus n equals to x minus n z squared is equals to n. So next thing is to divide both sides by x minus n z squared. So we'll do that. Y will be equals to n over x minus n z squared. So y is not the subject of the relation. Solution number 1 is equals to n over 2 minus n squared over 5n. So we have to make n the subject of the relation. So let's simplify here. P is equals to LCM of 2 and 5n is 10n. 10n into 2 gives us 5n. 5n times n will give us 5n squared. 10n to 5n will give us 2. 2 times n squared minus 2n squared. So let's eliminate 10n. So we're going to multiply both sides by 10n. So 10n is p. 5n squared minus 2n squared over 10n times 10n. So 10n here 1, 10n here 1. So 10n p is equals to 5n squared minus 2n squared. I'm going to move this okay, so let me erase this part here. So subtract 5n squared from both sides. So 10n minus 5n squared equals to 5n squared minus 5n squared minus 2n squared. So this will cancel, plus 5n squared minus 5n squared will be 0. 10n minus 5n squared plus minus 2n squared. We want to make 2n squared. We want to make n the subject formula, so we don't want a negative sign, so we eliminate the negative sign. To eliminate this negative sign, we need to multiply through by minus 1. Multiply through by minus 1. So minus 10n p minus 5n squared is equals to minus 2n squared. So minus 10n p plus 5n squared is equals to 2n squared. So if I write it the same, 2n squared is equals to, write some first, 5n squared minus 10n. So remove 2, eliminate 2, so divide both sides, divide both sides by 2. So 2n squared over 2 is equals to 5n squared minus 10n p over 2. 3 over 1, 3 over 1, n squared equals to 5n squared minus 10n p over 2. So to eliminate the power, we take square roots of both sides. Take square roots of both sides. So n squared equals to, got a plus or minus 5n squared minus 10np over 2. So 2 also n equals to plus minus square root 5n squared minus 10n over 2. So now now n is the subject of the relation. To find correct utility significant figure, the value of n when p is 14. So remember this is Roman figure. So write that again. N is equal to plus minus 5n squared minus 10n p over 2. So we see where p is 14, and then n is equals to minus 8. So n is equals to plus or minus square root 5. N is minus 8 squared minus 10 minus 8, and p is 14. N plus minus 8 times minus 8 is 64, plus 64 minus 8 times 14 minus 112, minus 112 times minus 10 is plus 1120. So 5 times 64, 5 times 64 320. So 320 plus 1120 1004, 1440. The square root of 1140. Square root of 1440 is 37.9409472 and what? The question says we should correct our answer to three significant figures. So this is the first, this is the second, this is the third. So to three significant figures will be plus minus 37.9 approximately to 2SF. That's the answer, 37.9. So the answer could either be plus 37.9 or minus 37.9. That's the value of n. So E is equals to m over 2g v squared minus u squared. We have to make u the subject of the formula u. So for us to do that, let's eliminate 2g. So multiply both sides by 2g. So 2g times e equals to n over 2g v squared minus u squared times 2g. 2g equals 2g. So 2g e equals to m v squared minus u squared. So because u squared is enclosed in brackets and it's still connected to v by u, we're going to open the bracket. 2g is equals to n v squared minus n u squared. Now we're going to subtract, eliminate but eliminate instead of going to that long process, just bring mu squared to this side and bring some to this side. So when this term with this negative sign attached to it crosses this equals to sign, so turn positive. So n u squared equals to n v squared. When this one crosses over, it's positive here, but because it has a crossover, it will turn negative, minus 2ge. So we want to make u a solid formula. We don't need n, so divide both sides. Divide both sides by n. So u squared equals to n v squared minus 2g over n. So we want u to stand with the not u squared. So how do we eliminate the power? Take square root of both sides. Take square root of both sides. So u squared square root is equals to square root n v squared minus 2ge over n. So u is equals to square root n v squared minus 2ge over n. That's it. I'm not supposed to use lowercase e. I'm supposed to use uppercase because that's what the question provided. E. So changing it to uppercase, and uppercase. You can stop here, but you can still simplify it further. So u is equals to square root n v squared. Since we have a common denominator, it means n minus 2ge over n. 2ge over n. Okay, so the next thing is, and this is you. This part is equal to what you have here. So u is equal to square root n to v squared minus 2g over n. So either this or this is correct, any of them. what I did was just simplify it further to get to this point. So at this level, it cannot be simplified any further. Number 3, make K the subject of the relation. T is equal to square root TK minus H over K minus H. So we want to make K subject formula. What we need to do first of all is to eliminate the square root sign. So we're going to square both sides. Square both sides. So T squared is equals to square root TK minus H over K minus H. So we have to cancel this. So we let it C. So T squared is equals to TK minus H over K minus H. So multiply both sides by K minus H. So we do that, we start with T squared K minus H plus a TK minus H. So because we want to make K solid formula, K is on both sides of the equation. Let's open our bracket. T squared K minus T squared H. This will give us TK minus H. So we're going to collect terms in K together. Collect terms in K together. So here is TK. So TK, this T squared K move out to meters become minus T squared K. And now we have minus H, and here's minus T squared H. So this will move over becomes H minus T squared H. So now factor out K. So K is equals to T minus T squared plus H minus T squared H. So the next is divide both sides. Divide both sides by T minus T squared. T minus T squared. K T minus T squared over T minus T squared is equals to H minus T squared H over T minus T squared. This will cancel. So K is equals to H minus T squared H over T minus T squared. K is the subject of the relation. Therefore, A is equals to P 1 plus R over 100 is 1 power T. So in this question, we have to make R subject of the relation. So for us to do that, first of all, we need to eliminate P. So divide both sides by P. So V over P is equals to P 1 plus R over 100 plus power T over P. P1 P1. So V over P is equals to 1 plus R over 100 raised to T. To eliminate T, we're going to take the T roots of both sides. Take T roots of both sides. Take T roots of both sides. That is raise both sides. So raise both sides. So 1 over T. So V over P plus 1 over T is equals to 1 plus R over 100 plus T. I'm raising this part to 1 over T. So from our indices, A 1 over X equals to root x e times x root x e. That's what it implies. So if here is 27 and you have a 1 over 2, it means the third root of 27. That's equals to 2. So here we're going to have c root v over p equals to, yeah, t times 1 is t. 1 over t times is t over t. So t here 1, t here 1. 1 over 1 is equals to 1. So here we raise to power 1. And anything raised to power 1 from indices is equal to that same thing. So 1 plus r over 100 raised to power 1. If you raise it to power 1, it will still give us the same value. So no points. So now we have this. The next thing is to eliminate 1. So what we do is subtract 1 from both sides. So we're going to end up with t root of v over p minus 1 is equals to 1 minus 1 plus r over 100. So I want to bring this part here and bring this part here. So 1 minus 1 is 0, so r over 100 is equals to t root v over p minus 1. So I need to eliminate. So we want to make r self formula, but r is connected to 100 by division. So eliminate with 100, multiply both sides by 100. So 100 r over 100 equals to, that's one, t root 100 here, 100 into 100 is 1. So r is equals to t root v over p minus 1. So this way, r is the subject of the relation.